Hello everyone, Assalamu alaikum rahmatullah. Thanks to everyone who are watching this video. We will start our third lecture about the number systems. We learned about the number conversion in our last videos. Today again we will know about the number conversion, but today our topic is number converting from other number systems to decimal number system. We have already known about the classification or type of the number systems. The first one is decimal number, and the base value of the decimal number is 10 and the numbers are 0 to 9. The second one is binary number, and the base value of the binary number is 2 and the numbers are 0 and 1. And the third one is octal number. The base value of the octal number is 8 and the numbers are 0 to 7. And the fourth one is hexadecimal number. The base value of the hexadecimal number is 16 and the numbers are 0 to 9. A as 10, B as 11, C as 12, D as 13, E as 14, and F is 15. So this is our number system that we use. Okay, we will change a number from binary or octal or hexadecimal format to decimal number format. At first I want to tell you everyone, if you don't know about the number systems, then at first please watch the last videos first about the number conversion, then you can understand everything about the number systems. Okay, so we have to follow some rules if we want to convert a number from binary or octal or hexadecimal format to decimal number format. So the first rule is determine the positional value of each digit. So what does the first rule mean? If we take a number of 1, 2, 3, 4, then the position value of 1, 2, 3, 4 will be count from right to left, and it will start from 0. So for number 4, the positional value will be 0. For number 3, the positional value will be 1. And for number 2, the positional value will be 2. And for the number 1, the positional value will be 3. If we take a number of 1, 2, 3, 4.56, then what will be it? As the point refers the decimal point, and this divides a number into two parts. One is integer part and the another one is fractional part. The right portion of the decimal point refers the fractional part and the left portion of the decimal point refers the integer part. Now we will set the positional value for the integer part and also the fractional part. At first we will set the positional value for the integer part. For number 4, the positional value will be 0, and for number 3, the positional value will be 1. For number 2, the positional value will be 2, and for number 1, the positional value will be 3. Now we will set the positional value of the right portion of the decimal point. For number 5, the positional value will be -1, and for number 6, the positional value will be -2. Now we will turn our second rule, where we will set our positional value as a power at the base. We will take a number of binary and the number is 101.01. Now we will set the positional values of this number. At first we will set the positional value for the left portion, and after that we will set the positional value for the right portion. And the left portion is called integer part and the right portion of the decimal point is called the fractional part. We have already known this. So for number 1, the positional value will be 0, and for number 0, the positional value will be 1, and for number 1, the positional value will be 2. Now we will set the positional value for the right portion. For number 0, the positional value will be -1, and for number 1 the positional value will be -2. Now our second rule will start. As it is a binary number, so our base will be 2, and we can write for every digit for this binary number. For digit 1 we can write 2 inverse square, and for digit 0 we can write 2 inverse 1, and for digit 1 we can write 2 to the power 0, and for digit 0 we can write 2 to the power 1, and for digit 1 we can write 2 square. If we will take an example of octal number, we have already known about the octal number. Here we will take an example, and our octal number will be 257.34. so we will set the positional value first, and then we will set the power at the base. So our positional value will be 0 for 7, and for digit 5 the positional value will be 1, and for digit 2 the positional value will be 2. And for the right portion we can write for number 3 the positional value will be -1, and for digit 4 the positional value will be -2. We will apply our second rule. We can write 8 inverse square because 8 is the base of the octal number. For digit 4 we can write 8 inverse square, and for digit 3 we can write 8 inverse 1, and for digit 7 we can write 8 to the power 0, and for digit 5 we can write 8 to the power 1, and finally for digit 2 we can write 8 square. We will take another example of the hexadecimal number, and the hexadecimal number is A57.B4. At first we will set the positional value of the left portion of the decimal point, and finally we will set the positional value of the right portion. For digit 7 we can set the positional value 0, for 5 the positional value will be 1, and for A the position will be 2. Now we will move on the right portion, and we can write for digit B we can write -1. -1 is the positional value, and -2 is the positional value of the digit 4. Now we will apply our second rule, and we can write 16 inverse square because 16 is the base of the hexadecimal number. For digit 4 we can write 16 inverse square, and for digit B we can write 16 inverse 1. For digit 7 we can write 16 to the power 0, and for digit 5 we can write 16 to the power 1, and finally for the digit A we can write 16 square. Now we will move to our third rule, and our third rule is we will protect the digits with the positional values with base. We have already seen the example. This is the digits and this is the positional values with base. Now we will multiply the digits with positional values with the base. So we can write 1 into 2 inverse square, where 1 is digit and 2 inverse square is the positional values with base. Now we can write 0 into 2 inverse 1, where 0 is the digit and 2 inverse 1 is the positional values with base. Now we can write 1 into 2 to the power 0, where 1 is digit and 2 to the power 0 is the positional values with base. Now we can write 0 into 2 to the power 1, 0 is the digit and 2 to the power 1 is positional values with base. Finally we can write 1 into 2 square, where 1 is digit and 2 square is the positional values with base. So we have already applied our third rule. Now we will apply our last rule. Okay, so our last rule is we will calculate the sum of the products. Okay, from the rule 3 we multiplied every digit with positional values with the base. Now we will do the sum of the products. If we do the sum of the products, then we will get 4 plus 0 plus 1 plus 0 plus 0.25, and if we finally do the sum, then we will get 5.25. This is our expected decimal number from binary number. This is the example of the octal and hexadecimal numbers. we can convert the octal and hexadecimal numbers to decimal number in the same way. Everyone completes this task. If you face problems while doing this, let me know in the comment section. Everyone stay safe until the next video. Bye bye. Allah Hafiz.